In this video, we'll be touching on the rate of reaction. Different chemical reactions take place at different speeds. For example, rusting of iron and oxygen is a slow reaction, and the explosion of chemicals is a rapid reaction. In this video, we'll be discussing four main factors that can control the rate of reactions. And they are concentration, temperature, surface area, and the presence of catalyst. The influence of these factors on the rate of reaction can be explained by collision theory. According to this theory, in order for a chemical reaction to occur, it must obtain effective collisions between the reacting particles. And effective collisions must meet two criteria. First, it must have enough speed and energy, and second, it needs to collide at the proper direction. The first factor that can affect the rate of reaction is concentration. As you can see, at a lower concentration, there are lesser reactant particles. At a higher concentration, there are significantly more reactant particles colliding into each other. Let's look at an example. In one experiment, magnesium strips were added to the test tube containing different concentration of hydrochloric acid solutions. And we noticed that a solution with higher concentration dissolved the magnesium strips more efficiently. So why does the speed of reaction increases at high concentrations? At high concentration, there are more reactant particles per unit volume to collide into each other. This increases the frequency of effective collisions and thus increases the rate of reactions. Temperature has the biggest effect on rate of reaction. The reactant particles move slower at lower temperature because they have little energy. When the temperature is increased, the particles gain energy, move faster and collide into each other more often. Let's look at an example. Solution of sodium thiosulfates at different temperature were acidified to form sulfuric acid and salt sulfur. And the result shows that the reaction proceeds at a higher speed at higher temperatures. So how does the temperature increase result in an increase in reaction rate? Well, we know that the increase in temperature really means that the average kinetic energy of a sample is increasing, and this has two important consequences. First, reactants particles move faster, resulting in increased frequency of effective collisions. Secondly, more particles will have the minimum activation energy needed to react, so overall, a larger percentage of successful collisions would occur. The third factor is surface area. Increasing the surface area of a reacting substance will result in an increase in reaction rates. This works in the same principle as concentration by generating more successful collisions. Except for concentration, we are physically adding more particles, but surface area talks about how those particles are arranged. If I have a big block of substance, the collisions are limited on the surface area. And if now I take this block and cut it into four, the number of particles remains the same, but the surface area that are exposed has increased for collisions to occur. And you can see that this effect will be significantly magnified if I keep on cutting into small pieces. For example, into two flasks, hydrochloric acid was reacting with marble chips and powdered marble respectively to produce carbon dioxide. And the speed of carbon dioxide gas produced in the flask containing powdered marble is significantly faster than the other one. From this, we know that the surface area is directly proportional to the rate of reaction. The presence of a catalyst is another factor that influences the rate of reaction. A catalyst is a substance that increases the rate of reaction without being used up or permanently changed. And the way it works is pretty interesting. It works by lowering the activation energy for reaction, so essentially it makes it easier for successful collisions to occur. For example, in two separate beakers, sodium tartrate was reacting with hydrogen peroxide, and one of the reactions in the beaker was catalyzed by pink cobalt ions. We can see the solution with the presence of catalyst almost instantly started experiencing color change from orange to yellow, green, and finally become pink. However, the reactants without a catalyst had no sign of reaction until it was heated on the second day. So how does the presence of a catalyst stimulate the rate of a reaction? The catalyst provides an alternative pathway with lower activation energy. From that, more reactant particles meet their energy requirement to collide, so the overall percentage of effective collisions increases, causing a high reaction rate. Let's summarize the key ideas we discussed. The increase of surface area, temperature, and concentration for reactants creates higher frequency of effective collisions, and the presence of appropriate catalyst also lower the activation energy for reactant particles to collide, which essentially increase the rate of reaction.
created using Powtoon.